After Milner Oakley, HOD is Professor J. Rajeshwari Tadi. Okay, so we are happy to be associated with the Singbath College. So because SK Singbath College is a famous college in Pune, which is located in Lonavala. It is having a series of multiple institutes. It is having a series of multiple institutes in the particular location overall surrounding Pune. Okay. Uh, so today the communication, first of all, before going to the underwater communication system, we ought to know about the communication systems. The communication systems era started over the year of 90s. Okay, so 1900s. Okay, so on that period, initially the communication happened with wired. Okay, so the communication happened with multiple devices. No, not happened with multiple devices. It happened between simply one-to-one device, that like information transmission with wire. At the end of 1800, 19th century, so it started to evolve. Like it will be evolved with the antennas, with the incubation of antennas. When antennas came into the attack, it is automatically going to wireless communication systems. The wireless communication system is already grown up to 100 years of era. Okay, so so these wireless communication have been driving us in this period about 1G, 2G, and 3G, and 4G and 5G. This is a communication transmission crossover is happening. Okay, so this communication era started in the year of 1970s when the computers have been taken into growth effect. So on the same period, the particular uh, communication, wireless communication also taken into account. So on the period of 1G, the communication happened with wired only. So plus wireless also happened with the broadcast systems. Okay, so like FM, otherwise for emergency medical situations, the broadcast has been happened. So likewise, TV communication. TV communication not happened in the 1980s period. 1990s period, that because of the high bunch of data rate availability with wavelength, so automatically the communication has been established high over. So at the year of 1990s, the TV communication made a higher bandwidth, so higher standard televisions have been available in the market. So automatically the communication happened between in the broadcast channel itself. Okay, so after that 2G came into era. 2G when because when the 1G is happening, there is a need of communication between multicast, like one person to another person should be communicated. So on that time of period, the communication started to be multicast. So the 2G communication came into account, which is called as a TDMA 2. And after that TDMA era, it just came into like 3G communication, when the data rate should be higher, like each person needs to be high use a high data rate. Automatically 3G communication is needed. So on the period of 2000 2005, on the period of 3G communication has been enabled, and after that 4G also enabled. Nowadays we are using the 4G in highly. 3G and 2G also available in the market, but the 4G is highly used one, because of the data rate and application availability, and highly usability, like HD transmission and all happening. So around we are using 4G, and the 5G is gonna come, because 4G is a base of the 5G. In the future, 5G is gonna come. 5G applications and all, we will be speaking about the upcoming seminars. Okay, we will be having some seminars in the future also in 5G. In this week itself, available, I think so. So on the seminars, we will be having the information sharing about the 5G. Rather than that, so this is the growth in happened between these period, like in wireless communication. Okay, so while this happening, there is a communication happening in the communication is not happening in the only wireless communication, which is a multipath communication happening with the city, the particular region of communication. It is happening in the worldwide also, like satellite communications and all available. So these and are also available. And likewise, underwater communication is also inaccountable. Okay, so today's the session is going to be underwater communication. Why we are considering the underwater communication as the session means, there is a lot of troubleshoots. Troubles are available in the communicating with the in the underwater. Okay, because all are speaking about the communication happens and the data rate improvisation in the uh, uh, air media or wide media. but we are not about to speak about the water, okay, underwater. So why the underwater communications and all needed, that and all we have to speak. Likewise, what's the problematic situation, uh, how it is solved until this time, and how it can be advanced, and how the data rate can be enhanced, and how the algorithms can be applied. And we will be seeing a algorithm with that some demonstration over this period in this session, okay. So with this we'll be going on this session. Myself Rajkumar, I am engineer at Pantech Solutions Private Limited. um, okay, we'll go on, okay. So first of all, if you want to go, first of all, you have to take the underwater communications. We have to see the applications. Why the underwater communications is needed? Okay, because without knowing the applications, we are going into the thought of ideologies. Means it is not suitable for productivity or reaching out the people. Okay, so we have to know the applications. So first of all, the applications is underwater divers. You might know the underwater divers. You might also go to diving, like when you are taking in a sea or oceanic regions, diving people will be there. They will be helping you out. So likewise, some people are doing research and all, means they are also doing the underwater diving. So these peoples need a communication environment to go under the sea, okay. So but the problem is here is underwater communication is nowadays also having troubles. We'll be speaking out on the upcoming sessions, okay, upcoming slides, okay. Next is seismic monitoring. Seismic monitoring is a major ideology, because tsunamis have happened with earthquake in the, because without if you are doing the seismic monitoring and underwater itself, we can identify a tsunami occurring in a particular ocean region. So then we can evacuate the people in the particular region surrounding cities, or surrounding cities people, otherwise surrounding regions who aren't all available the seashore of the particular region. So seismic monitoring is an important thing while going on to the underwater communication system, okay. So likewise, ocean's current monitoring. Ocean's current monitoring means underwater transmission is happening, line transmission is also happening. So all over that we have to identify what is the power transmission happening over the lines, okay. So for that we have to identify the uh, um, uh, uh, with the underwater communication system only, we can identify and we can give the solutions and information to the particular transporting region, okay. So likewise, autonomous underwater vehicles, uh, like nowadays we are having autonomous vehicles which is working in terrains, or water, otherwise any otherwise air, okay. These like vehicles will come under in this sea or ocean regions also, because always a man cannot be identifying the problems in the sea or ocean regions with his eyes, okay. So this is not possible. So autonomous vehicle should be there. So autonomous vehicles, if they are there, means multiple autonomous vehicles should be communicating over the particular period of time. So then only they can stipulate the information to everyone, okay. So the communication happens between multiple devices, so then only it can reach the interconnected devices, okay. So likewise, pollution monitoring and fisherman it's not happening in the underwater, it is overwater communication only. But underwater it can be enabled. When you are using an underwater communication, it is favorable to fishermen too. So likewise, military applications. In military applications, if you are taking, means when particular submarines are there, then submarines should be communicated with the particular base stations. So for that we have to make the communication. Nowadays the submarines are not communicating with the other base station directly. If they want to send the information or receive the information, they have to go, they have to place their ships over the water, then only they communicate, okay. So because the time per particular time of period they will go over the water, otherwise they will use using a transponder which is placed over the particular ships in the over water region, okay. So with that transmitter trans receivers, so automatically they will be having a receiver to receive the signal, and will be using to uh, telecast the information and receive the information from the base station to them, okay. So this is happening in the underwater communication system as an application. Likewise, fishery mapping. Fishery mapping nowadays happening with the satellite. With the satellite, they are capturing the images and they are locating where the fishes are available highly. So fisherman can be located over here to get the fishes. That like they are locating. But in future, we can use the communication systems to make the fishery mapping with the automatically identified with the cameras. The cameras can communicate with the device with the camera. You can communicate and we can send the information to the other device also, and we can get the ideologies where is the fisheries have been available. Okay, so communication channels, I already spoke about this one. What is communication channels? Like wired and wireless, and with this we are taking the twisted pair, coaxial and optical communications are there, like this terrestrial, satellite and broadcast. You might see in this one. Okay, so this is a communication channels are available mediums. Okay, so we are going with this is overall. Okay, so next we will be going with okay. So underwater communication medium, which is like coaxial and fiber optic also there, because most of the UAV vehicles like robots and all, after that submarines also, likewise who are available with cameras with underwater divers also using the fiber optic communication to send the videos or capture data anything to the over water at the particular time of period. Because if it's a live telecast they want to mean, they want to use a fiber optic nowadays, because the data rate is also high with the fiber optic only. They are using the majorly wired medium. Okay, so the wireless communications are available with acoustic and VLC. Okay, acoustic communications, it is like a vibration based. When you are making a pressurizing a particular media or material, the automatically it will be generating a vibration which is will be reflected by the another material, another device, which is a reflection will be occurred and will be analyzed over. Okay, so okay, so the VLC communication is nowadays used in the IoT systems, but in futuristic they are thinking, because they are thinking to use in underwater also. Because VLC is majorly made for underwater communications only, because the communication data transmission of the uh, acoustic communication or sonar and all it's lesser. Okay, so then we can use the VLC as higher data communication medium. So we'll be speaking about that also in these upcoming slides. Okay. So the today's session will be like underwater wireless communications will be the major ideology. Okay. Okay. So first of all, Li-Fi. Okay, Li-Fi based communications. You can see the slide. When you are generating an acoustic wave, uh, so it will be generating a signals towards the sea in deep sea also. Okay. So likewise, you are using a microwave, so it will be lesser distance only. It will be propagating. Okay. So likewise, you are using blue laser or blue LED, which is a VLC communication area. Okay, with these both blue green lights are making high data rate. This is another fact. Okay, so blue green wavelength lights are making the data to be transmittable underwater and highly. Okay, so if you are going with the 630 nano micrometer uh, micrometer of wavelength underwater means, then only it can be transmitted. So the light can be rays can be highly distinguishably it will be going under the water high. Okay, so likewise laser communication and all, these this light makes high data transmission in visible area, like it is directly transmittable to the particular device. We can locate the device too. That are the advantages of Li-Fi. Okay, so these Li-Fi communication is in a research also. So we are going to say about acoustic also as the next slide. Okay, so acoustic based communication, if you are giving, it is giving when you are providing a force, like it's a pushing force, otherwise a particular axial force, otherwise a coordinated particular point of force, otherwise a pulling force, like removing the particular device is connected. Also, it makes a vibrations. Okay, these vibrations have been propagated to make a signal. Okay, these signals will be transmitted over the underwater region to reach out the particular examining the upwards opposite point. Okay, that is the acoustic communication ideology. The acoustic communication speed and all, if you are considering, means it is going around same speed of sound. Okay, not like light. because if you are considering VLC means it is a light based communication. So the particular speed of the light is 3 power 10 power 3 into 10 power 8, all people know, meter per second. So the same communication will be happening with the light, but this acoustic communication is much more slower, like speed of sound only. So it's like a propagation of sound waves only. Um, uh, so the speed is also lesser, okay, but the communication capability and sound is much more high, like capability is higher, okay. So likewise, if you are taking the sound waves, it is automatically affected by the heat or temperature over the particular region. So when the same property will be applied to the acoustic communications too. The vibration based communication also will make the same experience over the particular region, okay. Okay. So next what we are going to see means these acoustic communication we are going to analyze. With the communication analysis, we are going to analyze it to OFDM. So why I am taking the OFDM as the topic here means because already TDMA, CDMA and FDMA, TDMA, CDMA all have been having a drastic changes and have been advanced with the OFDM. So nowadays OFDM is under research. Okay, so OFDM and further communications are there. So OFDM is under research. So I'm considering the OFDM as the particular algorithm for the transmission ideology in this topic. Okay, so first of all we are going with the FDMA, frequency division multiple access. You might hear this one. This is an old type of communication which is happened to 1G, which is happening with one frequency will be allocated for a one user. Like one user will get a one frequency. That particular frequency will be used for telecasting for the user. But you can take a broadcast. Like if you're taking a big FM, otherwise any FM stations, they will be having a one frequency for settlement, like 93.5 something 91.1. So that like frequency stability will be that frequency they will be tuning out. The receivers will be having the receivers. Those are receivers will be tuning out to reach the particular signal which is transmitted by the particular broadcast station at the other end. Okay, so that's the ideology of FDMA. Likewise TV, whatever it is, okay. And TDMA, it's like a time slotted communication which will be having a particular user will be allocated the time slot which is having a trigger frequency of region. Each time slots will be allocated for each user. In that user particular time slot, a user data will be placed out and it will be transmitted to the particular user at the remote. Okay. Okay. So next is CDMA. CDMA is like same like TDMA communication. This is slotted communication only, but here it is not slotted with one. Not only slotted, it is having a over power waveforms. Like the particular signal will be encoded with the power. Okay, like if previously if you are seeing it's not encoded with power, the power is placed in a unity manner. So the particular time slots will be varied highly, but here the power slots have been increased. Why they are increasing means automatically when you are using power slots, we can transmit a lot over region. The CDMA doesn't came at the year of 2005. Okay, it is came at 2000 itself. Like when the 2G came, the CDMA also came, the 3G concept also came. Uh, then the CDMA is enabled with the W, like wideband authorized. With that the wideband authorization, automatically it came to the high band communication to generate a high band data rate to the particular user. So then we can see use a video call or video transmission at live streaming and all be done with the CDMA itself. Okay. Uh, Next is OFDM, which is a major topic we are going to see about today. The OFDM, orthogonal frequency division multiplexing, which is including of FDMA and TDMA, which is advancement too of FDMA. Not like a TDMA, it's major advancement on FDMA. The FDMA, the problem with multiple frequencies, when you are transmitting one data on one frequency means the next frequency also will be affected. You can see the in the FM. Okay, when you are having a tuning range of 93.5, if you are tuning about 93.6 also, it will be affected by another signal. Okay, so what is happening here? So the signal is affected by the another signal nearby also. So the multiple resemblance of nearby signals will make the FDMA to be more noisy. So that's a problematic here. Okay, these should be removed out. Okay, this will be removed out. So for that only the OFDM came with the orthogonality, like orthogonal frequency division multiple axis. Okay, so what is happening here? The signals will be orthogonally phase shifted. Okay, so like 90-degree phase shifted will be there, they are done. So with that, the frequency the signals will be easily received to the particular receiver without making the noise with multiple signals in a one frequency time slot. So the data rate calls also can be improvised. The signal also noise level also will be decreased. So a lot of advantages will be there in the OFDM. So I have placed the typical OFDM architecture for underwater communication. I have considered this model. Okay, it's not it's not a finalized one. I have considered this model. I have placed with advanced blocks like data source and turbo coder, turbo encoder and a mapper like modulation schemes will be there. And after that, serial to parallel conversion. And after that, we'll be having a IFFT block. Like IFFT block means when the frequency to conversion they are to when the signal is in a time domain, you have to convert to frequency domain. Then only it can be transmitted. So we are using IFFT block for the OFDM. What IFE does, will be getting information from upcoming slides. So if that information be transmitted to the underwater channel with the noise. So after that, the reception will be done over the receiver side. So automatically the receiver will be having the reverse propagation what is done over the transmitter region. Okay, this is the overall scope we are going to analyze today. Okay, so next slide. So next slide we are going to OFDM introduction. You can see the OFDM introduction guard band will be fixed. Okay, so like when the particular frequency division multiplexing will be there, it will be having guard band, which is removing the noise between the multiple two bands. Like so, but the guard band when you are placing the guard band, that particular frequency having any guard band, the guard band is removed. The guard band is a waste of frequency because frequency demand is happening all over the world. Why I am telling the frequency demand means because microwaves can't be used for the communication between the mobile devices because mobile devices are multipath in environment. So multipath environment we can't able to communicate with the microwave device. When you are placing the microwave device in your mobile, it will be bulge and it is because microwave is a mostly line of sight communication. When you are communicating to device, when it is in line of sight, it can be communicated and it will be giving the efficient outcome. But if you're taking the non-line of sight communications and all, it is problematic. Okay, so we can't able to use the microwaves. So when we have to come under 3 gigahertz frequency, under 0 to 3 gigahertz frequency, that's a problematic area. So in this 3 gigahertz only, we have to use the efficient data transmission. But the users are higher here. Here we are using a particular region, a bigger cities like Chennai and Mumbai, Kolkata. If you are taking means the data, the particular users are available in a particular cell itself in a higher manner. That makes a problematic situations. That is a then the using at guard band and all, it is a waste of frequency. So we have to remove that one. So OFDM does that one only. When you are seeing the OFDM channel here, you'll be having a 90-degree phase shift between the four each and each signal. We are taking the red signal, it's 90-degree phase shifted with the green signal. The green signal is shifted with the blue with the purple. Okay, so that is happened here. Okay, so OFDM working method, you will be confused with the OFDM working methodology. So I will explain in a simple manner. Like if you are taking a wideband channel, we are transmitting into FDMA, we will be having a full of truck like manner, we will be sending the data. But if you are using a narrow band channels, when you are separating into small sub channels with the orthogonal sub channels, then the data will be splitted out and with the reception also will be increased because what will be happening with the wideband channels means the data will be lost when the particular noise is affected with the particular overall channel. Okay, but here when you are taking the narrowband channels, when the data is lost to the particular packets might lost in the particular track. Okay, there's a I mean, setting as an example. So then the loss will be not a major issue. Okay, so that only we are considering here with this methodology. Okay. Okay, OFDM signal processing I am again explaining here because I have placed a series of slides for making you be comfortable to view. What I have told that one only. What's the difference I am showing here? Like if you are seeing means what's the FDMA relaxations of frequency and what OFDM make it to be better. Okay, so here if you are seeing means you can see the FDMA when 10 channels should be transmitted, it is making a bulge amount of frequency. Just consider it is 10 megahertz. Okay, Then if you are going to the OFDM, it is 5 megahertz. So 5 megahertz elaborated highly. So the 5 megahertz can be allocated to the another 10 users. No, not 5 megahertz won't be allocated for 10 users. Automatically it will be allocated lesser only. I'm telling for example. Okay. So the 5 megahertz can be used for another user. So the data rate can be enhanced because why the data rate can be should be enhanced means multi user communications are available means one user is available in a queue means another user also will be affected. Okay, that should be avoided. So for the avoiding only we have to place a multiple band association in a single propagation with this with lesser bandwidth. So that's a major ideology. So that only we are maintaining. So here we are obtaining up to 50% of bandwidth affection capacity improvisation. So with that here OFDM how it will be distributed. Okay, if you are having like a how 90 degree phase shift he is telling how we will be doing, that is a one doubt you might have. Okay, so here it is having signals are there. So with that different phase shifted signals also there. So here it can be broadcasted with a different phase shifted with a different modulation schemes. So then we can enable high data rate communication too. That is shown here. We are seeing means first signal will be having a different frequency and different amplitude. Second signal is having much more higher frequency and much more higher lesser amplitude. And third signal much more lesser higher frequency and much more lesser and amplitude. Okay, so the different variation is shown here. Okay, but the time is same. Okay, this time is relaxed with the same time period with the different three signals have been accumulated with the different frequencies. Okay, the next is multipath fading. It is happening in the not happening in the underwater. It is underwater too. It will be happening in future if you are communicating in multipath. In future, it might happen. Uh, but multipath fading will be happening in the outdoor open area communication. That is a problem. So these multipath fading will be analyzed in the underwater also. What is happening in the underwater communication also will be analyzing. The Rayleigh fading, Efficient fading will be considered over the overwater air communication area. Okay. So likewise, OFDM will be having a guard interval. Guard interval means when you are sending a signal seriously, continuously, some signals will be having different time periods. Okay. So first consider direct signal is available, and second consider reflection signal, and the third consider reflection signal. You consider this multipath propagation environment. One signal is receiving directly, another signal is going upwards, and it is going to receiving. It is hitting over the T, and it is receiving to the particular vehicle. Okay, likewise it is hitting over the particular another area, and it is receiving over the vehicle. Okay, but the user is same and the transmitter is same, but the signals have been propagated and different delays have been estimated to reach a particular user. That is happening with the OFDM also in highly, because you are already OFDM is a bandwidth is bandwidth, various packet of bandwidth has been enabled. Okay, various packet of bandwidth has been enabled, so this makes already the situation worsen. So when then the particular signal is delayed also, it will be highly worsen. Okay, so that should be cleared off. Okay, so for that we have to use a guard interval. The guard interval is the interval applied over the initial time of period when the reflections of signals are happening over the period. Okay, so this guard interval is variable. Like a guard interval, if you are placing means what will be happening means if the signal is delayed also, sometimes the direct signal will receive in a faster manner, and another second signal will be received somewhat small slower manner, and another signal much more smaller slower manner. Okay, so consider this scenario. So if it is received much more delayed also, it won't be affecting us. Okay, it will be received in a same time period because of this guard interval. This is the advantage of guard interval. The guard interval is a major advantage and a major research area also too, for you people. If you are doing any researches, it will be, you can research in guard interval also. I have worked with guard interval papers also. So that is also an ideology. Okay, next is Wolfram spectrum utilization is available. Here the IFFT, how it is applied. Okay, one signal in time period is taken means how it will be applied in the IFFT. First of all, why we are using the IFFT, it might be a question for you, because of the formula like 1 by 2 pi root of 2 pi integration or summation of f of x into e power minus j2 pi ft. Okay, this is a signal formula for IFFT. Why we are considering this means f of x is a signal here, and e power minus j2 pi ft is the frequency and time period. The time period is a recording of the original signal, what we are considering the time period, time domain, and the particular frequency is the frequency of the how to tell means the frequency of the communication, like how to tell means the frequency of the expected, like if you are sending on signal, I am having speaking of 20 kilohertz, okay, already human will speak at 20 kilometers signal only. If you want to send in a 900 megahertz, so then we want to tune it, the modem should tune it, the frequency is modulating that one, so frequency is the that point of course we are considering, okay. So when here we want to consider the 900 megahertz, it could be changed over to the 900 megahertz. That's a ideology of the frequency. So the IFFT scheme is applied for that purpose only, because we are having multiple uh, uh, particular frequency bands, small bands. That band should be integrated. So we can use the butterfly like architectures. You might hear about butterfly diagram with the IFFT. So that will be enabling. So nowadays we are using a with the OFDM, the advancements have been done. Like OFDM, DWT is also working down. Like this, OFDM with multiple different frequency transformations also is under research. Okay, like OWDM. In future, it is coming with 5G with OWDM and all. It's also having the research on the OFDM with the different transformation schemes also. You can do research in over this area also. Okay. So I'm just showing with the different signals how the frequency is manipulated. If you are seeing the original signal is available, next it is having another signal with next time period. Okay, so different signals when you are joining it having a multiple frequency transmission with orthogonality we are defining with the IFFT. So the IFFT is a major play role of this OFDM. Okay. So y is equal to hx plus n is it's already known. So it's a OFDM or normal architecture. OFDM initially will be having a modulation schemes like QA modulation, BPSK, QPSK. You might heard about these in these your lower level of studies like in communication systems and all. If you are doing a B Tech and B means you can see in third year or fourth year. Okay, so these are the communication modulation schemes of the basic modulation scheme of the starting block of the any communication systems. Okay, and after that IFFT will be applied. After that fading channels will be applied. After that the receiver signals will be taken and FFT will be applied, and the decoded with the demodulation scheme will be happening. I don't want to explain elaborate because if you want to explain means it is a bigger process. Okay, if you want to explain the core modulation, PPSK, BPSK, if you want means I will be having, I can give you a future sessions too in this. You can give your feedbacks in your in our post. On the post you can tell what are the sessions I want to take in future, because for taking a communication system, so you can tell us a communication system, so what is your feedback and what is your expectation of the communication systems, or what are the topics should be included in the future sessions also. You might place it. Okay, that's I can check it and I can come to you. Okay. Okay, next is ASK, FSK, PSK. Like ASK, amplitude shift keying, FSK, frequency shift keying, and PSK phase shift keying. So ASK already this will be having amplitude variation. Whenever amplitude is there, the signal will be propagated. Otherwise, it will be having zero signaling. And FSK is a frequency based modulation. When the particular signal is having a higher amplitude, automatically it will be the frequency will be tuned out. Then PSK is a phase shift keying. Phase shift keying it will be happening on the period of it will be having a different phase modulation when it is starting from 0 degree towards 90 degree, otherwise 0 degree towards inverse minus 90 degree. It is based on the approach you are taking on the 0 and 1 bit. Okay, like this binary phase shift keying, BPSK, which is same as phase shift keying. Okay, and quadrature amplitude modulation. It is like advantages or advancement of amplitude modulation only. It is happening with a different amplitude variation only. With the particular amplitude variation, we can make a QAM 4, QAM 8, QAM majorly used are QAM 4, QAM 16, QAM 64. COM 2 to 6 up to is used. After COM to 6, 56 it won't be used. Why it is not used means when you are going with the higher modulation schemes and noise is affected over this particular signal, it will affect the overall signal. So then if it considering underwater area, when you are sending a data rate of light with higher data means, So if one data is lost means we have to retransmit again and again. So the data rate won't be improvised above 256 bits always. Okay, it will be considered always in the 256 form. They won't go improvised stage. Okay, that is another ideology modulation scheme you have to consider. And after that, intersimple interference is considered in the underwater. The multipath propagations is available. When multiple signals are propagated, it will be having multiple line of sight views, and it will be having a due to the line of sight changes, and it will be reflections, it will be happening automatically. It will be having a delay, so it will be having delay also. It will be having a change over the time period also. It may be having issues. So these are the distortion is there. I'm not telling the OFDM is a final solution. I'm telling the problematic areas also. Okay. So for this cycle prefix they are providing, I already spoke about the cycle prefix as particular guard interval. Sorry, cycle prefix no, I didn't spoke. So these like when intersymbol intervals are happening, the cycle prefix should be used. Cycle prefix should be like the final step of the signal will be taken and it will be placed over the near at the front. Like if you are seeing the OFDM symbols, and the last end of the OFDM symbol will be taken and it will be placed a cycle prefix. What will be happening means the cycle prefix only will be affected with the intersymbol interference also when you are transmitting. So that is the ideology of the cycle prefix and the OFDM data symbol. So that is another consideration which is doing with the OFDM. So you can do the research on the here also. This is also another area of research to be improvised. And after that, pilot carrier insertion is also there. Pilot carrier insertion, major research can be done because pilot is the major resemblance of a data at the receiver end. Okay, because when you are sending a data, you can consider like a pilot insertion. I didn't put a slide about pilot insertion. I will explain why my voice. Okay, when you're taking pilot insertion, a pilot should be placed in the particular signal. I will tell you the example. When you're sending a, if you want to send a one object to another person, you consider the object is a message. Your message you consider the message is taken by a one person to reach to the another end. You want to reach the particular time period of reaching is 1 hour you consider. But if you are reaching in a 1.5 hour of time period, you will be then the receiver should ask whom, whether he should ask a message or he should ask a particular person. He should ask the person. Why I'm telling the person means, because if it is it should be taken 1 hour, it is taken as 1.5 hour means it makes a delay. So the delay can be asked with the pilot. So the particular person is called here the pilot. So the pilot can be giving the information. The pilot will give the information. I have been reflected. Technically means it is reflected. Otherwise, I have been delayed due to the bus is not there. So that is another matter. So this is the ideology of pilot. The pilot will give the overall information of the path propagation from the transmitter to receiver. So the receiver can estimate the information from the pilot about the transmitting sequences, because the transmitting sequences won't be known by the receiver. So the receiver should have a connectivity of the information what has been exploited by the transmitter. So the pilot insertion is a major ideology and major advancement that has been done over the overall communication systems that is usable here also. Okay, so I am here considering the medium as underwater. So we have to speak about the underwater communication mediums and losses and issues and all over the particular underwater region. So first of all, I will specify the underwater medium losses. Then we'll go to the particular issues and we'll be having some formulas which is defining the underwater communication losses too. So first of all, absorption or scattering loss. Okay. So whenever you are considering the absorption loss, when a particular medium you are sending a data, like it by I consider like I am considering is a acoustic waves. Okay, so when you are sending an acoustic wave will have the issue with this, absorption or scattering. Like acoustic wave, it's like a sound only. So when you are sending a acoustic wave, the consequences will happen due to the heat energy, because heat energy will be transferred to the particular water, because the transmission of the underwater communication with acoustic, due to the heat energy, the signal will be affected first thing. Okay, so the energy will be distributed automatically. So this will reflect on the transmission loss. Likewise, these losses uh, uh, like scattering loss, when you are transmitting the water to depth water with a highly elongated area, we consider scattering loss to be on that region. it will be having a loss because a signal will be scattered over the region to the wide band of region. So it makes a particular region on the region signal to be lossy highly. Okay, so these signal losses will be considered as the cylindrical spreading or a spherical spreading. Why I am considering cylindrical and spherical spreading means moreover spherical spreading will happen when the tides are higher. Okay, but the cylindrical spreading will be happen to the depth waters because the depth water won't be, tides won't be issue. So when you are considering the spherical based spreading is happening, it will be happening in the over water only. Okay, so these are the ideologies of absorption losses. These absorption losses can be formulated. This formulated issue solution is with the TOPS formula. We have formulated the solution as a 10 log of A of f. Here the f denotes as frequency because when the frequency is increases, absorption coefficient also will be getting increased. Okay, so not only the f square is available, so it manipulates to increased. Okay, so this logarithmic solution is available here. Okay, so likewise, if you are considering the uh, uh, constant of absorption loss, which is multiplied with the logarithmic formula, will be for shallow water, otherwise like a low level water. If you are considering means it will be under 1.5 times. And if you are considering for depth waters, if you are considering for highly depth water like trenches, like you can hear about the Mariana trenches and all, it will be having uh, the issue with double the times like 2. Okay, to the factor will be 2. Okay, uh, next is uh, surface based reflections. Okay, surface based reflections means that when a particular signal is sorry, change the slide. When the particular signal is transmitted over the underwater or over water, the signal will be having a jumps between the particular regions of water over the water. The reflection will be happening to the roughness and smoothness of the water. Okay, this majorly it will be happening with the underwater air to underwater communication. You can see from the air, if you are considering like from a helicopter, they are sending you information. Otherwise from rocket they are sending you directly to the underwater means then the issues will be happening with the surface reflection. The surface reflection is placed over here. uh, so it is having a k as a factor. It will be varying with the angle too. So the it is not varying with the region, it is varying with the angle too. So it is presented as a formula here. And I am not explaining the formulas because it is highly derivative. I'm just going with the formulas and giving the final considerations and solutions have been met. Okay. Next is surface duct is also there. I didn't mention the surface duct. Surface duct is like a circular shaped circular shaped curvatures that has been created over the sea water. Okay, if you are considering a sea water, it will be having it small tides. So over the sea water, the circular surface will have the circular space like circles of placement, like it will be jumping over the waters to make a lossy informations. So then the delay will be increased, likewise loss will also be increased. And finally the ambient noise, it is not a final noise consideration. I didn't given us ambient noise. This is ambient noise. The ambient noise will occur due to the movement of ship and the wind and the thermal noise and the turbulence. Okay, these four considerations will make the signal propagation over the water much more complex also, because of the movement of ship, it will be having a tides generation and winds and thermal and turbulence will be met uh, with the effect of the mud. Okay, so that are the informations will be consideration. So under that considerations also I have given the formula. The overall noise will be having the enough with the particular noise notification of the overall logarithmic expansion. I am just added and I have placed it over. So with this, we are going to consider with this session on this OFDM channel with the uh, particular acoustic communication. What will be happening here? We have considered with beamforming too. Beamforming, you might not hear MIMO based communications, MIMO. Uh, multiple input, multiple output based communications. It is having some advancement. I will be giving a basic introduction about MIMO, and we will be having a session about the coding. Okay. So first of all, we have to know about these things before the going into the underwater communications. So here we having the bandwidth B and K, and what are the consideration I'm doing G as a guard time. It's like guard time, and after that, what are the pilot insertion? MS is a pilot insertion we are considering, and MO is a null carriers, and after that, original carriers will be considered as M. Okay, so these are the information I am going to place over the program also, so you can go get the information from there also. And MIMO beamforming technology, I'll go. So MIMO beamforming is like communication nowadays happening with Wi-Fi transmitters, or anything with base stations and all are happening. It is like a single point to multiple. Like it is not communicating to the towards a particular user who are available. In future, the communication will change. It will be happening with the beamforming based ideology. When the beamforming is happening, the particular user is available with which angle will be identified and it will be transmitted. So what will be happening exactly means the wherever the user is there, the automatically the user will be identified, predicted, automatically it will be propagating a signal over the particular user. This communication will enables the data rate also will be improvised, signal transmission also improvised, quality of service also will be improvised. So that is the ideology of MIMO beamforming based communication systems. So that has been produced as an image. Okay, here for your reference with the multipath air based communication, wired communication, it is shown here. Okay. Yeah, seeing means when you remove antennas have been placed, multiple devices are connected with the multiple beaming technology. So the particular device which is can be routed and it will be identified and it will be formed with the beam. So multiple transmitters are available also. So it can receive the particular signal from the particular angle in effective and effective solutional manner. Okay, that is a beamforming technology ideology. So when you are using the BEMO, how the data rate will be improvised, the power capacity of power can be improvised has been shown here. When you are having a CISO, it is having a 4 dB with dB of power capacity, which is called the logarithmic. When you are having considering the CMO, MISO, MIMO under the two antenna system, it is having 6 dB. When you are considering CISO as 4 dB, it is giving a 6 dB, which is a elongated, highly data, high power capacity enablement. If you are considering 4 antenna and 8 antenna, the enablement is getting multiplied and it is getting increased. Okay, when you are considering only 2, 4, 8 antennas expectation, it is less. But if you are considering the data when the CMO and the multiple antenna variations, if you are doing, it is automatically improvised. So MIMO is giving a highly efficient channel capacity over the particular region. Okay, so it is giving a solutions for the users available. Okay. Okay. MMOC estimator is available in the receiver. So in this session, in the coding, I am considering MMOC estimator and zero forcing. So I have given the slide. MMOC estimation is which is happening with the zero minimization of the original error occurrence. Like when the particular reception of pilots are identified with the pilot estimation, it will be trying to estimate the original sequence of data which is transmitted. So with the channel considerations also will be considered. So for that MMOC is there. The zero, so it will be having a manipulation between the y is equal to hx plus c. So c will be under not consideration automatically. It will be having a y divided by h. So it will be having a estimation what is the h channel. With the channel estimation, automatically finally we'll be having MMC estimation. So here we'll be having a noisy recurrence, which is a sigma square in, which is a noise, and plus the original information, which is x, and fh and xfr is the cross correlation which is happening with the channel, and finally ryy is estimation, which is the uh, 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 covariance, which is estimated by the cross covariance of the channels and changeover, and finally the noise will be channel will be estimated to identify which is the changeover channel. If you want MMSC, I will be having a future sessions too. Okay. Um, so what is channel what is development environment? Most of the people will have, you are speaking about underwater and all, and after that you are going with multipath communication and wireless communication, all things you are speaking. What's the medium of analysis you are doing, and where you are going to analyze this one? It's not possible to analyze all these sequence and things in the real time itself. We can consider the previous considerations what we have analyzed, the noise channel and all. With that information we have to analyze in the real time. We can't able to analyze the real time again, so we have to analyze in the platforms like scripting. Okay, with the scripting or otherwise the simulations, we have to analyze in our local environment with the PCs, and we have to estimate which algorithms giving the solution better. So with the noise estimated over the data transmitted. So like how to tell means like 1,000 bits are transmitted means how much bits can be received with the noise consideration. That should be analyzed and estimated. With the estimations we can improvise the algorithm, and with the estimators we are using means that also you will be improvising the algorithm. With that improvisation ideologies and all, we have to identify where is the issue and where how it is overcome. With that solution only we can go to the real time. We can't able to go to real time daily basis or directly with the analysis, because we can't able to base a base station and 1,000 users at a time to analyze with the base station. It's not possible. So we have to analyze all the things in a simulation environment to go to the real time after a bigger research. So Matlab is the environment here we are going to analyze with. So Matlab, all of you know, the software is developed by 1980s. Uh, uh, Clay Moller is the developer. So initially he developed for industrial aspects, but it then it started to change or evolve, and it is have been used in the various fields nowadays. So these are the informations about the MATLAB. You might know the MATLAB clearly because all the engineering students will overcome with the MATLAB. If anybody is not using also, you can get downloaded from the MATLAB website also to use it for the limited version. Okay. So next we'll go with the particular algorithm can be analyzed. Okay. Okay, here I am having the coding. Uh, I have done this for with different modulation scheme and different antenna the reference schemes and different estimator channel estimator with underwater environment. Okay, I'll go with QPSK modulation as a basic. Okay, so it will be easier to for you, I think so. So here we have made an initial consideration like 2 by 2 antenna is placed, transmitted 2 antennas and receiver 2 antennas, and I'm considering this antenna as a acoustic transmitter. Okay, don't consider like antenna is placed over the underwater. Don't consider. I'm considering acoustic transmitter has been placed as with the 2 acoustic transmitters and 2 acoustic receivers. Okay, so with that 8 I'm considering 8 lakh bits to be transmitted. Okay, with twice of the antennas, it is like 1,60,000 of bits, so it will be transmitted with the different antennas and transmitting. I'm just considering 1,60,000 bits to be transmitted. And here the FFT size, like FFT will be, should have the size. So 64 size is considered, and it will be having 52 carriers. In 64 FFT size of carriers, we are not using the all 64 data for data transmission. We are using only 52 carriers. Okay, we another 12 will be used for cyclic prefix operations. Okay, likewise iterations will be like 10,000, like 10,000 iterations we are doing with the particular data samples what we have. Okay, so here initially I am settling the SNR, signal to noise ratio. So signal to noise ratio I'm considering with logarithmic. So logarithmic the 10 power SNR of particular logarithmic sequence what we have generated divide by 10. The logarithmic is considered here as a divide by 10. Okay, so with that modulation scheme 4-bit modulation is done. So with that I am going to start the transmission ideology. So initially I am having the modulation scheme B. with a it is higher than, sorry, here it is BPSK consideration and rename this QPSK, sorry. It is higher than zero point 0.5 means it's considered as 1, and lesser than 0.5 means it's 0. So the BPSK data will be taken. So automatically what now 0 communication data will be taken, bits will be taken. These bits will be assigned with different carriers. So here we will be having 64 carrier transmission. So here is the manipulation of 64 carrier transmission ideology. Minus 26 to minus 1, one carrier topology is 26. Here another minus plus 1 to plus 26, another 26. Totally 52 carriers will be taken for the data transmission. Another 6 initial 6 will be placed as zeros, okay, and last 6 will be placed also with the zeros, okay. So we can making the 64 carriers, okay. Then we are using the IFT over the Excel of the data we are taken for the one antenna, with the second antenna also is taken, which is IFT made, and after that cycle prefix is done. Cycle prefix is done for the last 16 carriers data will be assigned to the front, okay. So for that what we are doing means we are placing the last original signal with the last 16 carriers, placing over the placement, okay, as a front, okay. So with that placement I'm going, okay. So here it is placed with last 16 carriers as a front and original carrier data, okay. So here also last 16 carriers and original carrier data. So with that we are having the originally placed data, right? So totally 80 samples per cycle, okay. So automatically we will be having 2 antennas, and with that we are having a channel of transmission, sorry, channel transmission here it's considered fading. I'll change that to 1 minute. Okay, I have made for 64 okay. So okay, so here is the channel of transmission which is considered for the underwater. For ambient noise only I have considered, okay. I didn't consider even for the other losses. I have considered for ambient noise and multipath propagation or the underwater channel underwater. So multiple noise have considerations have been also done over here. The initial steps have been done with the production of the QPSK only, which is happened for 64 bit, and after that finally it will be having the noise consideration, and in the reverse receiver side the reverse will be propagated. It will be having the inverse which is happening in IFFT. It will be having FFT over here. With that FFT it will be having equalization techniques, which is I already told you about the equalization techniques what we have been using. Here the equalization techniques what is used means automatically y hat will be identified, estimated y hat will be identified. With that y hat identification, initially we are going with the 0 for MMSC calculations, which is having a h of inversion of h and modulation of I matrix of the number of transmitters. Likewise 04C, which is making the original MMSC affected signal with a 0 maximum as a minimum focusing manner. That is consideration as a formula here. So with that estimations, finally we will be considering the bit error rate and throughput rate and all other parameters. Why you are considering bit error rate as a major ideology means when you are considering 1000 bits should be transmitted, initially the SNR is 1 dB means it might receive uh, like 800 or 700 bits. The other 200 bits is the issue. You can't ask me 200 bits loss a simple issue. Why you are considering this much is a bigger issue? You can ask me easily. But the thing is, when you are transmitting of 100 Mbps, one bit is lost also. In 1 MB, one bit is lost also. What will happen means we have to delete the overall packet. We have to send recent 1 MB data is lost. What will be happening, these will be happened for multiple packets means what will happen, we won't receive any data. If one user can't able to receive a data means he should be retransmitted again, which makes the overload of the server, overload of the data packets, okay. So then the particular user should be cleared off only, then another user can come in that talk. So what will be happening in the sequence will be distracted. These issues should be reflected, taken out, so that only these should be considered as a effective manner as ideology. So I have considered it's for 1 by 1 antenna, 2 by 2 antenna, and 4 by 4 antenna, and 8 by 8 antenna.
Some backup files also will be there. I am just considering the performance plot, which is given with the different consideration and analysis of these. So I have worked with that one also. That informations will be considered with one by one different antenna of receiver receptions. So with that, I am just considering for the throughput rate over here. When you are considering the 8 by 8 antenna series, it is giving a up to 10 bits per second. When it is in a 0 dB, like it won't be in 0 dB, it's like 1 dB. Okay, in 1 dB itself, it is giving a 10 bits per second. Okay, when it is increased for 40 dB up to, it is giving up to 70 bits per second in a one frequency channel, which is a effective data rate transmission, which is not happening over the period of 2 by 2 antenna and 4 by 4 antenna, and even with single antenna. Okay, so this is the throughput outcome. Likewise, we can see for bit error rate also. So I'm running the. Okay, bit error rate is also there. I didn't check that one. So the bit rate data, if you are seeing, means initially it is having a 5 bits per loss of 10 bit. If it is sending a 10 data, 10 bits, it is giving a 5 bits loss. And it is improvised like 2 dB, 3 dB, 4 dB lines. It is improvised, and it is receiving like 100 bits. 7 bits have been lost. That like solutions. This is effective solutions. Okay. So these can be improvised with the dB also, but the dB improvisation is not possible when the particular user is in the end of the cell or in large distance or depth. Okay, so the depth or distance are varied, means that will be issue. Okay, so for that we have to check with that one also again. So I'm considering the dB, because I am considering the dB, I am not considering the distance in the underwater communication, means the dB is directly related to the distance. Okay, with the considerations, I have to analyze with the zero forcing, with the bit error rate, sorry, MMSC with the bit error rate, and with the likewise with throughput rate considerations, you can identify with different plottings and analysis. Okay, you can analyze this. Can analyze throughput, bit error rate, and like with different antennas, different modulation schemes. A lot of different analysis you can do in your own to make your research to be elaborated. Uh, I think I have concluded the session, because the session we have analyzed about the underwater, what are the applications where it can be applied, and what are the research areas, and what are the research areas under consideration. In futures and also we can consider the application. The underwater research area is a vague area, and not more people are using the research. So we can do research in highly effective and high high ideologies we can make in this region. Um, um, uh, if you have any doubts, you can query me on this session. I can assist you. Now I am go through with the commands only. Certifications and all, you can get all certification links under the description of this video. Okay, please go through it, and so you can get the information, and you can check it, and you can place the feedback. If you are placing the feedback, you are ready to avail the certification. Okay, so please kindly cooperate for fill up with the certifications. We have got a doubt from Tarun M Nair. Why is both same, 1 by 1, 2 by 2, and 4 by 4? 1 by 2 can it be different like 1 by 2? All are having like if you are considering CMO, it is a single antenna, single input, multiple output. Okay, so 1 by 1, 2 by 2, all are same, you are telling, not the same, because if you're considering 1 by 1 means one single path will be propagated. 2 by 2 means one antenna to 2, another antenna to 2. So 4 paths will be propagated. 4 by 4 means automatically will be coming under 16 paths. The path propagation is the ideology. Okay, so when you are placing the higher amount of path propagation, you'll be getting reaching out the data rate with multiple paths with multiple data. The data improvisation will happen automatically. Okay, the power of data will be improvised. Okay, so so Tarunam Nair, so it is having a difference. Okay. Mm, any other doubts? You can check it out and place it over here. Tarunam Nair, I have replied. I think so. Um, what type of ML can be used to route the information? Priya, uh, actually, I'm not the ideologist about NS2 because you are asking the routing protocol and all is based on NS2 network simulations. Okay, reinforcement learning based ideologies are there. I have gone through it, but I don't have the much more ideologies. But if you are having a routing protocol ideologies and all, you are to having a memory. Okay, memory based routing will be have been done. Cell allocations will be done. If you want means I will check it and inform you upon the reinforcement learning and all. Can these be used in VxWorks? VxWorks, I have gone through the software, um, but Rashmi Sharoop, but I didn't. I gone through the software with VxWorks because it's mostly paid one. I think so. Uh, I will check it out. If anything is there, I will say, let you know with the next session. Okay, surely with the Rashmi Sharoop with the command you have given. I will let you know the next session with the 5G session. I will be having a ideology. I will be coming to you again. Okay. Okay, I'm closing the session. Myself, Rajkumar. I'll be having a future sessions too with you. I'll try to answer the questions you have placed under the comments. Uh, I have to show about the Singbat College at the end. So this is the official site of Singbat College. Uh, they have been available in this field up to 20, 30 years. Okay, now they started with 1992, I think so. So from that period of 1993, sorry, 1993 onwards, they have been working in these educations and knowledge of the people of the Pune-based region. It's the biggest group of institutions. It might here if you are available nearby in the Pune or in the educational site. Okay. Um, Likewise, you can get our information also from our informations, our needs, or anything, our solutions like projects or internships or any webinars. You can consult. Our website also is there. Okay. You can call our number 9840974407. Can come us in a chat also. You can WhatsApp us. Okay, for any certification. Actually, most of the people having issues with certification issues. I have heard a lot of things about that one. So you can ping us in WhatsApp. Like you can ping us in WhatsApp. The WhatsApp number we are majorly attending with the three numbers 98404407 and 7010 888841. Okay, so You can contact us for other details also. uh, if any issues are there also, you can come to us in anything like certifications and anything PPT or any requirements are there also. We'll try to sort it out in major. Okay. um, Thanks for joining with us. Thank you.